Alright, so we're going to look at some surface areas of prisms. And again, our prism has the same base on the top and the bottom. And we can unfold it into a net and then try to figure out our area of those pieces. So that's exactly what we do. We unfold the prism. It looks like that. There's three sides. That's a 6, that's a 5, that's a 12. And we really have four regions that we're trying to figure out the area for. 1 and 3 are the same. And it's just a rectangle, so it's 5 times 12 or 60. 2 is a rectangle as well. It's 6 by 12, so 72 square units, or centimeters in this case. And then 4 is a triangle, which means we have to find the area of 1/2 base times height. The base is 6. That side is 5, because we can imagine that this folds up on there, right? Or it's easier to see down here. This folds up there and fits exactly, so we have a 5 for that length. If I draw in the height, the 6 splits to 3 and 3, and we can find the height with the Pythagorean theorem. 3 squared plus something squared equals 5 squared. And we solve it and get 4. So I can find the area, 1/2 4 times 6, or 12. And then I add up all my pieces. So the surface area is 2 times 60, because there's 2 of those rectangles, 1 and 3. And then 72, which is the one in the middle. And then there's 2 times 12 for both of the triangles. And that gives me the surface area of 216 square centimeters. I can also look at the next one. Same idea. I'm trying to find the lateral area and surface area of the prism, and my base shape is a regular hexagon. So we're going to use our 1/2 AP to find the area of a regular hexagon. So to do that, we look at the lateral area, which is 6 by 12, which is 72, and there's going to be 6 of those when we get all of our pieces. So our lateral area is 6 times 72, or 432 meters squared, and that's just the outside pieces, not including the bases. So to find the surface area, we need to figure out the base. And if you remember, we have a hexagon. My area formula is 1/2 AP, where A is the apothem and P is the perimeter. So my central angle, this would be 60 degrees all the way across. I get half of it for 30. So I have a 30, 60, 90 triangle, where 6 is the hypotenuse. That means that is 3 and 3 root 3 for my other pieces. The 3 root 3 is the apothem, and then I'm going to use the perimeter to figure out the whole thing. So my area is 1/2 AP. It's 1/2 A is 3 root 3. There's 6 sides, and each is 6 long. That becomes my perimeter. So I get 54 root 3 for my area. Now to figure out the surface area, I add my lateral area plus the area of the bases times 2, because there's 2 bases. So I get 2 times my hexagons plus my lateral area, leaves me with around 619 square meters. For the third one, we're finding first surface area of a cylinder with a height of 10, a radius of 10 in terms of pi. So there's a cylinder. The key thing to think about this is if we unwrap it, I have 10 and 10 for those pieces. I unwrap it, there's a 10. What that corresponds to is this height goes to there. And then we got to be careful of this length is the circumference all the way around of my cylinder. So it becomes 2 pi times 10. That's my circumference formula on both of them. So the area I multiply, I get 20 pi times 10, or 200 pi. And again, that's my circumference. That's that length there. That's where that's coming from. So that's my lateral area. To figure out the surface area, you would have to figure out the bases. So that's a circle with an area of, or a radius of 10. So the area is 100 pi, 10 squared. There's going to be 2 of them. So 200 pi for the lateral area. Surface area is lateral area plus 2 times the circles, which gives us 400 pi for our final answer in terms of square centimeters. Alright, for number 4, we have this picture of basically a steamroller with a small circle, a small tube or cylinder in the back and a large one in the front, and it's moving along on the ground and making this asphalt flat. That's what the situation is. So we want to know how much area does a small drum cover in one turn. That's the lateral area. And so if I look at it, it looks like this. The diameter is 3, so the radius is 1.5. And it's 3.5 tall. So the 3.5 goes there, and I need to figure out the circumference, right? Because again, all the way around here becomes my width of my rectangle. So that's 3 pi. And the area would then be 3.5 times 3 pi, or around 33 square feet. Now the last one is a little bit, you got to think about it, but as this big circle, big drum is turning, this little one is turning as well. Now, when it's gone one full revolution on the big one, it's covered a certain area. This has to have covered the same area, otherwise it would have separated, right? It's a rigidly connected, so the distance has to be the same, so the area is going to be the same. It's doing it faster, it's doing more revolutions, but it's still covering the same area. And again, if we looked at it, right, it's 3.5 as a height, and it covers the same circumference as the large one because it's one revolution, so it's the same piece.